Hey, I'm Sarah, and today it's time for part 2 of my BLE Scanner app. So here I am in Android Studio, and I'm using Android Studio Giraffe. With this version, I can use device mirroring to mirror my physical phone right here in Android Studio. So here I have my phone loaded up, and let's go ahead and see what the app looks like. So when it first loads, the first thing it needs to do is check for Bluetooth permissions. So it starts with this Get Started composable, and I click Allow Permissions. And here we go. The scan starts, and these are my real Bluetooth devices in my house. And as you can see, I have the device name, I have a service if listed, and I have the date it was last seen, which automatically updates with each scan. And the RSSI strength also automatically updates as the scans complete. And all of this data is coming from my room database behind the scenes. So here's my physical phone. If I go in here and turn off Bluetooth, then it prompts me automatically that I need to allow this permission. And here we go. The scan starts back up again. And some other cool features is I'll go ahead and switch this to dark mode. So give me a second here. Dark theme. We'll turn it on. Oop. And let's go back to the app. And here's what it looks like in dark mode. And now also, if for some reason I go in and I remove the permissions, so let's go back to apps. And I'm going to go ahead and remove the location permission. And now if I go back to my app, this is great. It takes me back to the Get Started screen where I can re-allow the permissions. So I'll go ahead and allow them. And here we go. The scan starts again. And that's pretty much it for the user interface for now. There's still a ton of features to do, but let me go ahead and show you what the code looks like behind the scenes. So here in my Gradle file, I initialize all of my plugins, and most importantly, I'm initializing the Android JUnit 5 plugin. And for configuration, I have a custom instrumentation test runner for Koin, and I'll show you how that works in a second. And then finally, for dependencies, I have all of the basic Compose dependencies. I'm using Accompanist for the permissions. I'm also using Timber for logging. I have serialization. And I'm using Room, and here are all the Room dependencies. And I'm also using Koin, so I set up all of my Koin dependencies here, including Koin testing dependencies for all of my unit tests. And finally, for testing, here's tons of dependencies here for unit tests and Android tests. So let's go over, speaking of Koin, let's go over to my DI folder. And here's my app module. So I'll go over how all of these work, but for now, let's just go through the setup. So I provide my Bluetooth manager, which actually handles all of the scanning of the Bluetooth devices. So I create my Bluetooth adapter here. And as you can see, Koin lets you provide the Android application, which is awesome. Here, I actually name a dispatcher. I've learned to inject all of my dispatchers into everything that I can. And that way it makes it really easy for testing to inject a test dispatcher. So I'm also injecting some coroutine scopes. And here I create my BLE Manager. This I'm not going to demonstrate right now because it's not finished yet. And I also create my ViewModel here. Now in my database module, I provide my room database, and I'm creating this from an asset. So it's a pre-populated database. And if you haven't seen my first video, make sure to check that out because I preload Bluetooth companies and services. And so here I provide my database, my DAO, and my repository. And finally, this is my use case, and I have a parse scan result use case, and I'll show you what that looks like in a second. So these are all my Koin modules, and I load them up in my app. So here I inherit from application, and I create my app. and I go ahead and load up Timber. And then I start Koin, and I provide the Android logger, the Android context, and finally I provide all my modules. So here's my app module, my database module, and my use case modules. Here's the Material 3 theme for my app. And for this, I'm turning dynamic color off because I want my theme to come through in both dark and light mode. And notice how here the background actually extends through the status bar. So to get that to work, I had to set the status bar to transparent. So here, window.statusbar transparent. And then I set the appearance of my theme, so whether these show up dark or light. And then finally, this is the trick, set decor. You want to set it to false. And what that's going to do is extend my background throughout the entire screen. Here in my main activity, the code is pretty light. On create, I set up a BLE observer, and then I add this observer to the lifecycle. So let me show you what this looks like. In my app, I need to watch for a few changes. I need to watch for changes in permission, and I also need to watch to see if Bluetooth has been turned on or off. So to handle that, I inherit from the default lifecycle observer and also the Koin component, so I can use dependency injection. And here I get my BLE Manager and my adapter, and I set up my activity result registry. And then I set up my activity result launcher and my broadcast receiver. And then on create, I create my broadcast receiver. And what this does is here we're actually listening for the Bluetooth adapter action state changed. And if it's off, then stop the scan and go ahead and enable the intent to turn Bluetooth back on. And if it's on, then just make sure that it's scanning. And then so back here, I also register the launcher to handle whether Bluetooth has been turned on or off, because that needs to be handled by a launcher. And basically, if everything went okay with that, then go ahead and start the scan again. And then back in my main activity, once this is all set up, I just start my BLE app composable. And right now, this still needs a lot of work, but it sets up the basic background. And I'm using a PNG background for either the dark theme or the light theme. So I set that up here. And then I get my system bars padding to make sure that the device list has some padding from the top of the status bar. And so I go through the modifier and calculate my paddings here. And then finally, I load my home route. So let's go ahead and click into here. I'm trying to be really good about my previews, so I'm trying to add them in whenever I can. So here's one for the dark theme, and here's one for the light theme. So my home route takes in the view model, and it's a Koin ViewModel. And then I get my devices, which is coming from room. And here I'm setting remember multiple permission state, so I can remember this in my composable. And I create a launch effect, so if anything changes with the permissions, I'll know about it. And in the view model, I can say start the scan if everything is okay. And if everything isn't okay, this is where I actually show that get started screen. So it'll say, hey, get started, we need some permissions first. And let me show you what this looks like here. So let's go ahead and load the preview. So here we go, here's my get started screen. And basically this is just composable setup. I won't go through this in too much detail. But here's the key, multiple permission state, launch multiple permissions request. So Accompanist handles all of this for me. The key thing here is, let me show you in my util package, is I have these permissions defined here. So I have my permission list and I check my build version. And these are all the permissions that I need to add depending on the build. And Accompanist uses all of that to go ahead and handle everything for me. It was pretty easy to integrate. Oh yeah, and real important, for this preview, this composable takes a multiple permission state. So to make this work, I just had to create this object, multiple permission state, and then I just override the values and set them to nothing. So it's basically sending an empty object to the preview, and everything works great for that. So back in my home route composable, if everything's good with the permissions, then we can show the scan device list. And that's down here for now. I'll probably extract this out at some point. But this is super easy. It's just a lazy column, and it goes through the devices. And the scan device is also in a separate composable. So let's load up the preview here. And here we go. I've included the background in this because I wanted to see what it looked like with the colors against the background. And this is basically just an outline card. And this is composable set up here. Again, I won't go through this in too much detail. And then I have my preview down here. So let's go ahead and look at the view model next. This is just a pretty basic setup. It does use dependency injection for a few key components, including the BLE Manager, the repository, and again, I'm injecting all of my dispatchers. So here I'm getting the device list as a flow from my repository. So all of these devices are just coming from room, and I flow on the dispatcher that I've passed. And then I go ahead and share my state. And there's just a couple really simple functions to start the scan and connect to device. I'm not going to show that yet because, again, that's just not finished. That's a work in progress. Next, I'll go over the BLE scanner itself. So in my presentation layer, I have the BLE Manager. And here's where most of the magic happens. So this takes in my repository, a coroutine scope, and my parse ScanResult use case. So I set up a few things here, my adapter and the scanner, and then I configure my scan settings. And then I have a scan callback. And this callback, every time it receives a new device, it calls it my use case. So let's go ahead into here and see what that looks like. So in my domain layer, I have my use case here, and this again takes in my repository, and I can invoke it. And I set things up here. So this is the scan result, the actual Bluetooth device that comes back to my app. And first thing I do is check for manufacturer specific data. And I get the manufacturer ID. This is a sparse array. So what this does is basically goes through and gets the manufacturer ID. For example, Microsoft would be 6. So this would return 6 for me. And if I actually have that, then I get any manufacturer specific data. If it's there, for example, Microsoft has the Windows 10 device operating system listed. And if it is, I go ahead and I get that device. Well, first, let me show you how I read through the byte array. So let's see, go through here. And so here I pass in my byte array and I get the first byte and I convert it to hex and then to int. So let me show you real quick. I have these awesome utility functions that I've added to my app where I can take a byte array to hex. I can take a byte to hex. I can manipulate the UUIDs. So the Nordic database only stores the first part of some of the services, but the Android BLE API actually returns the full qualifier. So it's going to return something like this here. So it's going to return this string. So I have to manipulate it a little bit to make sure that they match when I do the comparison. And then in the scan results, the nanos come back. So I have to convert that to milliseconds. So I do that here. And then once I have the timestamps in milliseconds, I can convert that to a simple date format here. And that's what finally displays on the device list is the last seen date right here. So let's go back to the parse scan result. So if I actually find a device, then I go ahead and add that to my extra field that I've created in my data class. And then next, I basically go through the service UUIDs, and this is where it actually goes through and makes sure. So let's go ahead and go into here. So I have this list of parcel UUIDs. I go through and I check the service, and here's where I convert it to make sure that it's going to match what's in my backend room database. And if it does, if everything looks good, I add it to the list and I return my services as a list. So we'll go back here. So that sets up the services. And then finally, I set up my data class with the device name, address, RSSI, manufacturer, services, extra, and the last seen date. So here you can see I'm converting it to milliseconds. And then finally, I insert it into my room database behind the scenes. And that's it. The manager can do everything on its own. And then the view model picks up whatever is in the room flow with new devices and new RSSI values and things like that. So back in my BLE Manager, this is the on-scan result. And when it's initialized, I initially delete all of the scans from the table. I'm probably going to expand upon that and add some more functionality. But for right now, I'm just wiping out the whole table every time the app loads. And this is the scan function, which basically starts the scan with my scan callback. And this stops the scan here. That's pretty much it for the UI interface. Now let's go into my Android test folder. So for Koin, I created a separate application. So here I have BLE Scanner app test. And what I had to do is with Koin, I created singletons within the app, which works great because it doesn't matter how, I want the same instance every time throughout the app. But with testing, I want to make sure that I'm starting with a fresh database version every time. And I want to make sure that my tests are completely accurate. So what I do here is I create this separate application. I provide the test context here, and then I'm providing separate modules for each of my Koin dependency injection definitions. So let me show you my test database module, and let's look at the differences here. So this time, when I provide my room database, I provide it in memory. And for my DAO, this is the same. I still provide my BLE DAO, but I made a pretty significant change here. So in this module, I've created a Koin scope, and it's scoped to the test BLE database. And for each scope, I provide the test database, the BLE DAO, and the repository. And so this is a really important difference from the app. So let me show you. I actually create a separate database here. In this version, I'm still adding my entities here, and I still have my type converters, only this time I'm adding a BLE DAO and a test DAO. And the reason that I did that is because my app loads from a pre-populated database, and that database includes Bluetooth companies and Bluetooth services. But when I load my database from in-memory, I don't have these options available. So what I needed to do was in my testing, I actually needed to insert some of that data into my in-memory database. And these methods or functions, they really didn't belong in my BLE DAO because they just really didn't need to be there. So what I did, I just created a completely separate one. And this inserts the services, inserts the companies, and inserts the Microsoft devices. So that way I have some separation and I'm not really duplicating too much code. So I'm not worried about things getting out of sync or anything like that. So to make loading this pre-populated data easy and convenient, I created a JUnit 5 extension. So this Koin test per method takes in my database, and it's a before each callback and an after each callback. And before each, it goes ahead and takes the database with the test DAO, and it inserts my services, my companies, and my Microsoft device. And then after each, it closes the database. So that way, for each test, I can make sure that I'm getting a clean database and a clean test, and I don't have to worry about any kind of data integrity problems or anything like that. So now when it comes to the actual test, in my pre-populated repository test, I basically have it per method now. I used to have it per class, but I changed it to per method. And I inherit from my Koin test. And then here's where the scopes come into play. So I create my test scope, which is, if you remember from the DI package here. And we'll go into the database module. So here's my scope here. So I created in my test, and then I used the test scope to get my database and my repository. And then I register my extension. So before each test, it's going to go ahead and insert the pre-populated data. And then finally, after each, it closes the test scope. So that makes sure I have a brand new object each time that I'm testing. And then finally, I just simply run my tests. I make sure that I can get the company ID, and I assert on that, and I make sure that I can get the services by ID and get the Microsoft device by ID. And if you watched my previous video, I also made some changes to my other unit test that I have. So the DAO test, again, it's all pulling from this test scope. So make sure to check out the changes here. And then finally, the addition for this video is I've added, let me close some of this. So I've added some device tests. And again, we start per method. And I create my test scopes. I register my extension. And here, this is really cool. So it's pretty difficult to mock the ScanResult callback and to mock a device for Bluetooth. I did the best I could. I used MockK to mock a lot of the responses, and I also tried to use a lot of real code whenever I could. So to create the device, I create a mock class, and then for every device get address, I return this fake address here, and then for every get name, I return this name. And then again, I mock the scan record, and for every manufacturer-specific data, for this instance, I'm returning null. But for this test, I wanted to actually test the service ID. So here we have a complete service ID, similar to what would come back from the Bluetooth API for Android. So then I create my scan result, and I am able to do that somewhat for real. So I can pass the device in, and I can pass the event type and all these values, the RSSI. I can pass in my scan record, and I can pass in a nanos timestamp. And then finally, this is really cool. I'm calling my real use case. And this is great because that's exactly what I wanted to test, was to make sure that the scan result, when it comes into the use case, that it can actually parse all of the data properly. So it goes through and actually inserts it into the in-memory database for the test. And then we make sure that we can find it in the database. And then I run my assertions here. So I can make sure that the name is correct, the service actually comes back correctly, and the RSSI comes back correctly. And then I do the same thing because I wanted to test the Microsoft device. So for this one, I'm actually providing the manufacturer data as a byte array. And this is really cool because this is exactly how my use case would take in the data. And I've actually zeroed the rest of this out because I'm only interested in certain bytes. So then I go ahead and set this up to return the array, and get manufacturer specific data is 6, and I make sure that it returns my byte array. And then again here, I set up my device. I call my use case, and then I check the database and I make sure that the device comes back like it should. So I make sure that the manufacturer actually says Microsoft and that the device is Windows 10 desktop. And again, I check my RSSI. And that's pretty much it for this round. There's still so much more to do. The next implementation will be actually to click on the device and connect to it and observe the services and get some characteristics and fun stuff like that. So that's it for now. Thanks for watching.